Hi everyone, and welcome to Geometry Lesson 5.1, Perpendicular and Angle Bisectors. Now, before we get into our lesson, I would like you to think about what some words mean. First, think about what perpendicular means and what bisector means. And what you're going to do is you're going to take that and put it on a Google Doc that you're going to turn in as your classwork for today. The next word I want you to think about is equidistant. Equidistant. Think about what that sounds like. Think about the words it sounds like and think about what it might mean. So pause the video right here. On a Google Doc, write in what you think perpendicular bisector means and what equidistant means. And then press play and we'll talk about what these words are. So while you were thinking about the words perpendicular bisector, I hope you remembered that perpendicular means that it's two lines or segments that meet at 90-degree angle. Okay, and it says it's a bisector, which means that it's going to cut a segment exactly in half. So we have a line that's perpendicular to a segment at the segment's midpoint. Okay, now equidistant means it's an equal distance. Equidistant. So it's an equal distance from two or more objects. And finally, locus is just a group of points that satisfy a given condition. Now, this is a word that I didn't tell you previously to think about because I knew that most of us probably haven't heard this word before. Okay, but it's a group of points that make a condition true. For example, a circle, the technical definition is that it's the locus of points that is a certain distance from the center of the circle. So it's a group of points that's maybe 2 inches from the center. Okay, so that's what a locus is. Now let's take a closer look at perpendicular bisectors. So the perpendicular bisector theorem says that if you know that something is perpendicular and bisecting a segment, then you know that if you pick any point on this line right here, any point, we picked X right here, then that point is going to be an equal distance, equidistant, from the endpoints of the segment. So if we know that we have a perpendicular bisector, then we know that AX is equal to XB. Okay? Now, the converse says if you know that AX is equal to XB, then you can conclude that line L is perpendicular and bisecting AB. Okay, so it's the complete opposite. If you know that these two things are equal, then you know that this meets in a perpendicular manner and is bisecting the segment. Okay, let's take a look at some examples. Our first example gives us this picture right here, and they want you to find the length of WY. So notice what they've told us. They've said that the line L meets XY in a perpendicular manner, and it cuts XY into two equal parts. So this would be an application of the perpendicular bisector theorem because we're told it's a perpendicular bisector. So I know that WY has to be equal to WX. So WY is 7.3. So your final answer would be that WY equals 7.3. And you would also want to note the theorem that you used. This was the perpendicular bisector theorem because we knew it was perpendicular and bisecting before we even did anything else. Okay, let's take a look at another example. Okay, so we have this picture right here, and we know that AC is 36 and AB is also 36, meaning that these two segments are equal. Now, down here, they've told us perpendicular, but they didn't tell us bisecting. Because they didn't tell us both perpendicular and bisecting, I know that they want me to apply the converse of the perpendicular bisector theorem. So because these two things are equal, I know that BD is 16. But that's not what they asked for. They asked for BC. BC is the total length. So if this is 16 and this is 16, then the total is going to be 32. So BC is 32, and we applied the converse of the perpendicular bisector theorem. So for this one, again, it's important to show how you got your answer. So BC is 2 times 16, which is 32. You could also write 16 plus 16 here. And then don't forget to note the theorem that you used, converse of the perpendicular bisector theorem. So we have one more example to take a look at. In part C of example 1, they wanted you to find the length of PR. So again, please note the symbols that they've given us show that we have bisected PQ and line L is perpendicular to it. So that means that we're using the perpendicular bisector theorem. And what that says is 2n plus 9 has to equal 7n minus 18. So we're going to write an equation and solve it. So let's see how that goes. So the equation I wrote is 2n plus 9 equals 7n minus 18. And the thing that allows me to write that is the perpendicular bisector theorem. Now we need to solve it. So I'm going to start by subtracting 2n on both sides to get my n's to the same side. And that's 9 equals 5n minus 18. Then I'll add 18 to both sides to get 27 equals 5n. Then I divide it by 5. 27 divided by 5 is 5.4. Now, it's very tempting to say that you're done, but remember our ultimate goal was to find PR. So we need to take that and put it into this expression for PR. So we get this. PR is 2 times 5.4 plus 9, which is 19.8. And that's the answer for this question. Now, on your response doc for this lesson, you have some check it out questions to do. So here they are. They want you to find each measure. In question 1a, they said given that line L is the perpendicular bisector of DE, and EG is 14.6, find DG. And then given that DE is 20.8 and DG is 36.4 and EG is 36.4, find EF. Now, one thing that isn't written here that I definitely want you to do is I want you to write down which theorem you used. Make sure you note which theorem it is before you say that you've gotten your final answer, okay? So pause the video, do that, and then press play to see the rest of the lesson. So now we're going to talk about angle bisectors. Now, if you recall from what we've learned in the past, an angle bisector cuts an angle into 2 equal parts. So it's a ray or a segment that goes through the center of an angle and cuts it into 2 equal parts. Now, the angle bisector theorem says that if you have an angle bisector, so if you have an angle cut into 2 equal parts, then you know that any point on this ray, if you find the shortest distance from that point to the side of the angle, it will be equal to the distance to the other side of the angle. So you know that AC is equal to CB. Now the converse says if you know that these 2 parts are equal, then you know that it's an angle bisector. You know this angle is cut in half. Okay? So let's take a look at some examples. Again, remember, it's all about what you know first. If you know the angle is bisected, it's the regular theorem. If you know that you have 2 equal parts, then it's the converse. Let's take a look. Okay, in this case, they wanted us to find the measure of LM, which is this segment here. Please note that they've said that the angle is bisected. They said this part here is equal to this part here. So what that means for us is that JM and ML are equal. So ML is 12.8, and we know that because the angle was bisected. So this is the angle bisector theorem. So my final answer for part A is that LM is 12.8 because of the angle bisector theorem. Now in part B, they want us to find ABD. That's the angle, ABD. And they've told us that AD is 74, DC is 74, and the big angle, ABC, this big angle, is 112. So this is actually the converse of the angle bisector theorem, because they didn't tell us the angle was bisected, but we know that it is because these two parts are equal. So that means all I have to do is divide this by 2. And 112 divided by 2 is 56 degrees. So it's the converse of the angle bisector theorem, and the angle they wanted is 56 degrees. Okay, so here is our final answer. ABD is 56 degrees, and it's the converse of the angle bisector theorem. We have one more example with this. Part C said they wanted you to find the measure of angle TSU. So TSU is this angle right here, and they've only given us an expression. Now, notice what they have given us. They've given us an expression for the other half of the angle, and they've told us that these two are equal. Now, because these two are equal, we know that the angle is bisected. So this is the converse of the angle bisector theorem. And because the angle is bisected, I know that these two things are equal. So let's write an equation and note which theorem we used. So the equation I wrote is 5x plus 23 equals 6x plus 14. This is the converse of the angle bisector theorem. Now we just need to solve for x. So I'm going to subtract 5x on both sides to get 23 equals x plus 14. Then I will subtract 14 on both sides to get x is 9. But I'm not done there. I still need angle TSU. So I'm going to take that and put the 9 into this expression here. And my final answer came out to be that TSU is 5 times 9 plus 23, which is 68 degrees. So now you have one to try. In this check it out question, you need to solve 2a and 2b. And don't forget to write down which theorem you used. So read them carefully, write down the theorem, and find a final answer, and then press play to see the next example. In example 3, it says each pair of suspension lines on a parachute are the same length and are equally spaced from the center of the chute. How do these lines keep the skydiver centered under the parachute? So what they've told us is that the suspension lines are the same length. That means that PQ is equal to QR. Because they're equal, I know that QS is the perpendicular bisector of PR, meaning that PS is equal to SR, and the skydiver will always be centered under the chute, which is a good thing because if he's not centered, he will be spinning, and that would be bad. Okay, so he is always centered because he's on the perpendicular bisector. So we have one last example. I'm going to do that in a separate video. Don't forget to watch it. It's really important.